Hello everybody, welcome back to my channel. In today's video we'll be seeing a new topic, that is types of DC generators. So types of DC generators can be mainly classified into separately excited DC generator and self-excited DC generator. In separately excited DC generator, we use an external source like battery to excite the field coil. In self-excited DC generator, some part of the generated EMF which is generated itself is taken back as to excite the field coil. So in separately excited using external source, in self-excited some part of the EMF generated is given and taken as an excitation source to excite the field coil. Now self-excited DC generator is further divided into DC shunt generator, DC series generator and DC compound generator. In DC shunt generator, what is basically happening is that the field coil, the field coil and armature coil are parallel to each other. In DC series generator, the field coil and the armature coil, there's two coils, okay, field coil, armature coil. Remember this. Basically it's all about memorizing, so it's better to memorize. So field coil and armature coil are parallel in shunt generator. Field coil and armature coil are in series DC series generator, and in compound there is a mixture of both. Both is possible. Few turns of the field coil are connected in series with the armature coil. Few turns of the field coil are connected in parallel with the armature coil. Both. Now DC compound generators again further divided into long shunt and short shunt, which we'll be seeing when we are doing the diagrammatic representation. So I hope this is clear. Let me just quickly summarize again. Based on excitation, there is two classifications: self-excited and separately excited. In separately excited, we use an external source to excite the field coil. In self-excited, we use the whatever EMF is generated, some part of it is taken back and is excited, and it's the excitation of the field coil. That self-excited is divided into three parts again: DC shunt generator, DC series generator, and DC compound generator. In DC shunt generator, the field coil and armature coil are parallel to each other. In DC series generator, the field coil and armature coil are in series to each other. In DC compound generator, some turns of the field coil is in series with the armature coil, and some part of the field coil is in parallel with the armature coil. That is further divided into DC long shunt and DC short shunt. Now short shunt DC generator and long shunt DC generator. Now we'll be seeing each one of them, starting with self-excited DC generator. What we'll be doing is we'll be doing the circuit diagram, current equation, voltage equation. That's it. So let's start. Self-excited DC generator. The diagram, once if you learn, it's easy to understand. I'll draw a little big only. Okay, I'm your own teacher. Draws a first circle and then like this you'll draw. Then like this. Like this. Here load is going to come, and this is connected like this. This is going to be labeled as EG. This is IA. This is IL. This is going to be VT, and this is separately excited, right? So that field coil here, it's going to come like this, and this is going to be the battery. This is going to be I. This is going to be DC supply. Labeling and all is done. This is the field coil. Okay. So this is the diagram. First understand the diagram. If you once again will draw each errand twice, so we can draw. EG we have drawn. EG say outside what is going to come? IA. Then it's going to go to the load. So IL, VT. Here field coil. So IF and DC battery. That's it. Okay. So now what is going to be the current equation firstly? Okay. First let me tell the parts. IA is armature current, so R is going to be IA is armature current, R is going to be armature resistance. RF is going to be IF is going to be field coil current, that is going to be, RF is going to be field coil resistance. Eg is generated EMF across armature. Vt is terminal voltage. IL is load current. I repeat, IA armature current, IF field coil current. IR armature resistance, RF, sorry, let me write the parameters, I am only getting confused. IA armature current, IF field coil current, RA armature resistance, RF field coil resistance, VT terminal voltage, IL load current, then anything else. EG generated EMF across armature. 1 2 3 4 5 6 7 1 4 7, that's it. Okay, quickly I'll draw the diagram again just for practice. EG, then here you have IA, and this is going to go to the load, and this is going to be VT, this is going to be IL. It's separately excited, so this is going to be IF. It is DC battery, this is field coil. That's it, done. Okay, now let's write the current equation and the voltage equation. Current equation, look at the diagram carefully. IA is equals to IL. Whatever current is going to come as IA is equals to IL. This is correct. That's it. That's the current equation. Now coming to voltage equation. You don't have to write with respect to IF. Just write with respect to IA equals to IL. That's it. Voltage equation. EG. No, voltage equation is written always in terms of VT. Okay. VT is equals to EG minus IARA minus brush drop. That's it. You don't have to write it with respect to field coil. Just write this EG minus IARA and minus brush drop. That's it. You have to remember this. You don't get confused seeing IF, IL also is there. What should I write for that? Don't worry about that. IR is the armature drop. This is the brush drop. That's it. Is the voltage equation. Okay. So I write this also again. Current equation. IA is equals to IL. That's it. Voltage equation. VT equals EG minus IARA minus brush drop. So if I'm just going to combine, just show you for this. P out is equals to VT into IA. So what am I going to get? EG into IA minus IA square RA. That's it. Brush drop you're now going to write here. This is only P out. P out is basically what? Total power. Total power is what? Basically output power and losses. So P out is what? Output total power minus losses. That's it. Don't have to worry too much. This is about separately excited DC coil. So one of it we have completed now. First one, self-excited DC generator completed. Let's go to the second one. I hope this is understood. Whatever I have explained, I hope you have understood it well. So next one is self-excited DC generator. In that first one is what? DC shunt generator. DC shunt generator. So here what does it mean? The field coil in this type of generator, the field coil and armature coil are parallel to each other. That's it. Okay. So let's try to draw the diagram now. This is same. EG is there. Now it is parallel and it is means it is not separately set. It has to be connected together. So like this. And this side are same load. Okay, and here same RVT is what VT was there is going to be there. This is IL, this is IA, this is shunt. So ISH, and that's it. This is RSH also is there, and this is EG, IA, VT. So what and all is there? ISH is what? ISH is what? Shunt field coil current. Shunt field coil current. Before it was only field coil current, now shunt field coil current. IA armature current, IL load current, RSH shunt field coil resistance, RA armature coil resistance, VT terminal voltage. Done. EG EMF generated across the armature. That's it. Okay. Now let's write the current equation. Current equation. IA equals ISH plus IL. Correct? I equals ISH plus IL. That's it. Voltage equation. VT equals EG minus IARA minus brush drop. That's it. Don't get confused with anything else. In series it's a little different. When I'm going to talk about, I'm going to tell you that EG minus IARA minus brush drop. That's it. Finished. Second one also finished. Diagram once again I'll draw and show you. Just for practice. Load. Here VT. Here IL, IA, ISH, RSH. This is field coil. And EG. That's it. ISH is shunt field coil current. IA armature current. RSH shunt field coil resistance. RA armature resistance. VT terminal voltage. IL load current. EG EMF generated across the armature. That's it. Okay. This is also done. Second also is done. Let's move on to the third one now. Third one is 2.2. That is what? Same self-excited only, but DC series generator. DC series generator. There was parallel, right? Here it is series. So it is series. So like this you have to draw. Sorry. Load. EG. So IA, ISC, IL, VT. Done. So what are the parameters we have defined? ISC. What is this? What is this called as? Series field coil current. So RSC is what? Series field coil resistance. Series field coil should be there compulsorily. IA is armature current. Then RA is armature resistance. IL load current. VT terminal voltage. EG EMF generated across the armature. That's it. Done. Now current equation we have to say IA is equals to ISC and is also equals to IL. Now voltage equation if I have to say EG minus IARA. This was settled before. Now ISC RSC also we have to write. In shunt we did not write. ISH RSH we did not write. But in series we have to write. Remember this consciously. Drop across series field coil we have to write. Even in separately excited we did not write. It was parallelish only because it was separately excited. But in series when it is there, ISC RSC it should be there, and of course along with brush drop. Remember it consciously. Now because ISC is equals to IA, so EG minus IA into RA plus RSC also we can write minus brush drop. Diagram once again quick practice. Load. That's it. EG, IA, ISC, IL, VT. That's it. Finished. 2.3 also. 2.2 also done. Now coming to 2.3, which is compound generator. DC compound generator it is. In this again there's two types, long and short. So let's look at DC long compound generator first. It's also called as long shunt DC compound generator. Long shunt. Both of these are shunt. So let me say that only. Long shunt DC generator. Long shunt. Both of them are shunt type only. So EG. Here it's a combination of series and parallel. So series part is done here. And here is the parallel part. And this is as usual load. So this becomes IA, this becomes ISC, this becomes ISH, this is as usual VT, and this becomes IL. So RSH is also there and RSC is also there. So this is series field coil and this is shunt field coil. So IA, we know armature current. ISC, series field coil current, or just we can write it as series field coil current. And ISH, shunt field coil current. Similarly, RA, armature resistance. RSC, series field coil resistance. RSH, shunt field coil resistance. VD, terminal voltage. IL, load current. EG, EMF generated across the EMF. Done that much. Then now coming to current equation. IA is equals to ISC. This is one equation. And ISC is equals to ISH plus IL. ISC is basically what here? IA. So IA is equals to ISH plus IL. This is the current equation. Now coming to the voltage equation, VT equals EG minus IA RA minus ISC RSC minus brush drop. Same as series. If there is a series thing, then definitely we have to mention ISC RSC, that you have to remember. EG minus IA RA minus ISC RSC minus brush drop. Here again IA and ISC is same. So EG minus IA into RA minus RSC minus brush drop. That is the final voltage equation. Now this is clear. Diagram once again we'll practice. EG, series also should be there. This is long shunt. So this is going to be IA, ISC, ISH, RSH, RSC, VT, IN. Done? Okay. And I have already explained this. So I hope this is clear. Current equation, voltage equation done. Now coming to short shunt DC compound generator. This is short shunt, remember. So what is going to happen is that definitely C is going to be there, but here the parallel part is going to come from here itself, not from the beginning. Okay, and the rest is the same. Load. So EG, IA, ISH, ISC, IL, VT, RSC, RSH. So ISC is what? Series field coil current. ISH, shunt field coil current. RSC, series field coil resistance. RSH, shunt field coil resistance. IA, armature current. RA, armature resistance. VT, terminal voltage. IL, load current. EG, EMF generated across the armature. Done. Now let's look at the current equation. IA is equals to ISH plus ISE. ISC is equals to IL. From the image only you see IA is equals to ISH plus ISC. ISC is equals to IL. From the image only we can see. So IS is equals to IL. So can I write it as IA is equals to ISH plus IL? Yes, correct. Because I am just replacing this. Correct. Is done. Now coming to voltage equation, same thing. VT equals to EG minus IA RA minus ISC RSC minus brush drop. If series is there in the circuit, this must be there. But if shunt is there, not there also, we are not writing ISH RSH. Okay. So I've explained you all the how many cases did we see. One is separately excited. Then in self-excited we saw series, shunt. In compound we saw long and short. So 5 cases we have seen in this video. So I hope it has helped. So thank you for watching. See you in the next one. Bye bye.